And I think we finished page 2, right? The exercise at the top of page 2. Right? We learned about the distance formula yesterday. Just a reminder, right? This is the distance formula, right? The distance between 2 points in the coordinate plane. This is the distance formula. And these kinds of things you got to have memorized, right, for quizzes and exams, right? There's no cheat sheet. There's no formula sheet. It's all got to come from up here. And pointed out yesterday that formula comes from the Pythagorean theorem, right? Applying the Pythagorean theorem. All right, so let's go to the top of page 3 and tackle that exercise. As I get a swig of coffee. And we're instructed to find all the points on the y-axis that are 5 units from the point 4, 4 in the coordinate plane. So let's draw a picture. Here's the x-axis. Here's the y-axis. And here's the origin. So here's x equals 1, 2, 3, 4. Y equals 1, 2, 3, 4. And so here's the point 4, 4 in the coordinate plane. And so this makes this point right here on the y-axis, right? All points on the y-axis have 0 for an x coordinate, okay? So this point here on the y-axis, y equals 4, right, is the point 0, 4. Now, we got to find all the points on the y-axis that are 5 units from this point right here. Okay? Well, the distance between this point 0, 4 on the y-axis and the point 4, 4 in the coordinate plane, how far apart are those 2 points? Yeah, it's just 4 units, right? Because they have the same y coordinate. And so it's just the distance from here to here horizontally, which is 4 units, right? X from x equals 0 to x equals 4 units. So the points on the y-axis that are 5 units from 4 and 4, right, can't be this point right here. Like a point up here, that's 5 units from the point 4, 4. And then there's a point down here. That's 5 units from the point 4, 4. Okay? So there should be 2 of them. Okay. And so we'll label this point up here 0y, right? Because this point on the y-axis has 0 for an x coordinate and has some value of y for a y coordinate. And we could label this one down here 0y. So when we're going to take the distance between these 2 points, 0y and 4, 4, and set them equal to 5 units. And then solve for y. And when we do that, we're going to end up with 2 values of y. Because there's 2 points on the y-axis that are 5 units from this point 4, 4. Okay. So the distance from the point 0y to the point 4, 4 is 5 units. Okay? So using the distance formula, the distance between the point 0y and 4, 4 is equal to the square root of the difference in the x coordinate squared plus the difference in the y coordinate squared. From page 1, your handout. And that distance has to equal 5. Okay? And so now we're going to solve this equation for the variable y. Well, under the radical, you have to follow order of operations, right? PEMDAS. Parentheses comes first. So 0 minus 4 is negative 4. And then y minus 4 squared. Actually, let's write out minus 4 squared is 16. And then we got to expand y minus 4 squared. But remember, to do that, you got to FOIL. And so let's review. Foiling that for a second, okay, on the side. So remember, you multiply, right? FOIL stands first, outer, inner, last, right? So when you multiply first terms, you get y times y, which is y squared. Then when you multiply outer terms, you have minus 4 times y. When you do inner terms, you have minus 4 times y. And when you do last terms, you minus 4 times minus 4, which is plus 16. When you combine like terms, you end up with y squared minus 8y plus 16. So under the radical over here, we have y squared minus 8y plus 16. Combine like terms, 16 plus 16 is 32. So we have the square root of y squared minus 8y plus 32 is equal to 5. What gets rid of the square root on the left-hand side? So yeah, so we square both sides of the equation. We have y squared minus 8y plus 32 is equal to 25. So in this step, right, I square both sides. All right. And now I subtract 25 from both sides, right? You should recognize this is a quadratic equation, the variable y. So we subtract 25 from both sides. We have y squared minus 8y plus 7 is equal to 0. Two ways to solve this equation, right? One is by factoring, and the other is quadratic formula. Factoring is faster in this case. Okay. So this factors to the left of y minus 7 times y minus 1. So we have a product of two factors equal to 0. So by the zero product property, either the first factor is equal to 0 or the second factor is equal to 0. So either y minus 7 is equal to 0 or y minus 1 is equal to 0. By the zero product property. And so when you solve those two equations, you get y equals 7 and y equals 1. So these 2 points on the y-axis, there are 5 units from the point forward and forward plane. Okay, have a y-coordinate of 7 and 1. Okay. So the points zero 7 and 0 1 on the y-axis are 5 units from the point 4 4. Any questions on that? All right. So if you flip over your sheet, we're going to talk about the midpoint formula. Right? The midpoint between 2 points in the coordinate plane. So we've learned previously, right, how to find the midpoint on the real number line between 2 numbers. Now we're doing it, find the midpoint between 2 points in the coordinate plane. Okay. So, right, previously, we had the 2 numbers A and B on the real number line. The midpoint between those 2 numbers was just the average of those 2 numbers, right? A plus B over 2. That was where the midpoint M was. And so you notice that the midpoint formula for 2 points in the coordinate plane is very similar, right? We just average the 2 x coordinates. We average the 2 y coordinates. Okay. So here's my coordinate plane. Here's the point x1, y1. Here's the point x2, y2, right? Those are the coordinates of the 2 points. So I connect the 2 points with a line segment, and the midpoint of the line segment M. Okay. The x coordinate for the midpoint is the average of x1 and x2 for the first coordinate, and the y coordinate is the average of y1 and y2 for the second coordinate. So it's very similar. So in the exercise, you're asked to find the point B if the midpoint is at 5.5, 0, and A is at the point minus 4, 1. Okay. So let's draw a good picture. So here's the x and y axes, and here's like minus 1, minus 2, minus 3, minus 4 on the x-axis, plus 1 on the y-axis. So here's the point A, at minus 4, 1. And then the midpoint between A and B is at 5 halves, 0. Well, 5 halves is the same as 2.5, right? So here's x equals 1, x equals 2, x equals 3. So 5 halves is halfway between 2 and 3, right, on the x-axis. 5 halves same as 2.5. And so this is the midpoint M at 5 halves, 0, right? The y-coordinate 0, so the point's on the x-axis. Okay. So I got to extend my x-axis here. So the distance from A to M is equal to the distance from M to B, right? So I got to extend this line segment by the same amount. So B is down here somewhere. What are the coordinates for B? Okay. All right. So let's label B x2, y2. And A can be labeled x1, right? That point, minus 4, 1 can be labeled x1, y1. Okay. And so the midpoint formula has the x coordinate, right, for the midpoint formula is the average of the two x coordinates for A and B. And the y coordinate for the midpoint is the average of the two y coordinates for A and B. Okay? Well, we're given that the midpoint is equal to 5 halves. So the average of the two x coordinates for A and B has to equal 5 halves. And similarly, the y coordinate for the midpoint is the average of the two y coordinates for A and B. And we're given that is equal to 0. Okay. The midpoint has an x coordinate 5 halves and a y coordinate 0. Well, x1 in this case is minus 4. And y1 in this case is equal to plus 1. And so now we solve those two equations for x2 and y2, and we know the coordinates for the point B. Okay. So in this first equation, we're dividing by 2 on both sides. So to clear the 2 in the denominator on both sides, we just multiply both sides by 2, right? So when we do that, we have 2 times minus 4 plus x2 over 2 is equal to 2 times 5 halves on the right. Multiplying by 2 on both sides clears the fractions. And we're left with minus 4 plus x2 is equal to 5. So now we add 4 to both sides. So we get x2 is equal to 9. So the x coordinate for point B is 9. Okay. All right. So similarly, over here for the y coordinate, right? We multiply both sides by 2 to clear the fraction on the left. And we end up with 1 plus y2 is equal to 0, right? Because 0 times 2 is 2. Or 0 times 2 is 0. And now we subtract 1 from both sides. And we get y2, the y coordinate for point B is equal to -1. So, in conclusion, the coordinates of the point B are 9, -1. So the midpoint for point A and point B is 5.5. Any questions? Yes, sir.
So like on the quiz or exam, when we write the answer, do we need to write out the statement or do we just need to?
It'll probably be a space on the exam that says for you to write the answer, right, where what the coordinates are. But I like writing it up. All right. Any other questions? All right, so let's move on to section 1.4. So now you have everything you need to successfully complete the WebAssign homework for 1.3. So 1.4 has to do with the equation of a circle. Okay. So again, if you don't need a hard copy, will you please raise your hand when I get to your row? You don't need one. You don't need one. So I got 2 for the people in the back. All right. Circles. So before we talk about circles, let's define some terms, okay? An equation in 2 variables is simply a mathematical statement that asserts 2 quantities involving these variables are equal. So here you might recognize this as a quadratic equation in 2 variables. And so the equation asserts that the quantity y is equal to this quantity 3x squared plus 6x minus 2 on the right hand side. So y, right, is typically, well, let's reverse it. X is often called either the input variable or the independent variable. And y, conversely, is called the output variable or the dependent variable. And so the graph What's the graph of this quadratic equation in two variables? It's a graph of a what? Parabola. It's U-shaped, okay? The second equation, x squared plus y squared equals 16, is the equation of the circle. Okay. And the last one, x squared over 25 plus y squared over 9 is equal to 1. Now I'll try to draw this as best as I can by freehand. It's not very good. We do better than that. Does anybody know what that's called? It's not an oval for a racetrack. Right? It's called ellipse. All right. So the solution set for any equation is all the combinations of x and y that satisfy the equation. Okay. And with those combinations of x and y, right, you form ordered pairs, where x is the first coordinate, y is the second coordinate. Okay. The graph of an equation then is the plotting of all these points, all these ordered pairs, x, y, in the coordinate plane. Okay. The x-intercepts of a graph are the points in the graph where the graph crosses or touches the x-axis. So let me give you a simple illustration of that, the y-intercepts. So this is an arbitrary graph of an arbitrary equation, right? Students often ask me, where'd you get that? And I'm just pulling it out of the air. Okay? So here is the graph of an equation, okay? X and Y axis, graph of an equation, okay? Where it crosses the x-axis, here, here, and here, those are the x-intercepts. Where it crosses the y-axis down here is the y-intercept. Okay. So the x-intercepts are where the graph crosses or touches the x-axis, and the y-intercepts is where the graph crosses or touches the y-axis. Okay. All right. So now that we've talked about the definition of an equation, let's talk about the equation of a circle. A circle is a set of all points in the coordinate plane that are given fixed distance r, called the radius, from a given point C, called the center. So I'm going to draw a circle in the coordinate plane, and just to make things easy, I'm going to draw it in the first quadrant. Here's the origin, right? X and Y axis. And so here's my circle in the first quadrant. By definition, a circle is a set of all points x, y in a coordinate plane that are a given fixed distance r, called the radius, from a given fixed point C, called the center. So here's the center, and all these points on the circle are r units from the center. So the distance from this point to the center is our units, and the distance from this point to the center is our units, right? Every point on the circle is our units from the center. Okay. The standard form of the equation of a circle with center at point HK and radius R is given by this equation. X minus h squared plus y minus k squared equals r squared. So the center C here has coordinates h and k, right? H is the x coordinate, k is the y coordinate. So the center here, right, has an x coordinate of h and a y coordinate of k. Given h and k and r, the equation of the circle in standard form is this right here. Any questions on that? So you flip over your page. Now, when you do this, right, I use two columns, okay? Because not only do we have to get the equation of the circle, but we gotta get the x and y intercepts, right? So you may want to make judicious use of the space. And we're instructed to find the equation of the circle with center at -1, 3. Well, if the center is at -1, 3, h is equal to -1, and k is equal to 3. Okay, because h is the x coordinate and k is the y coordinate. Okay. So, standard form for the equation of a circle. Is x minus h squared plus y minus k squared is equal to r squared. So h is -1 in this case, so we have x minus -1 squared. And 3 is equal to k, so we have y minus 3 squared. And that's equal to the radius squared. We don't know what that is yet. Okay. So when we simplify, minus a -1 is +1. So we have x plus 1 squared plus y minus 3 squared is equal to r squared. So now we got to figure out the radius, right? Well, this circle, right, the graph of this circle passes through the point 6, 2. The x coordinate, right, for that point is 6, and the y coordinate is 2. So we can put 6 in for x, 2 in for y, and solve for r squared. You get the value of r squared, the value of the radius. Okay? Because this point has to satisfy this equation. Okay? Because this point is on the graph of this circle. So we put in 6 in for x, 2 in for y, And now we know what r squared is equal to. 6 plus 1 is 7. So we have 7 squared. 2 minus 3 is negative 1. So we have negative 1 squared. 7 squared is 49. Minus 1 squared is 1. And so we have 49 plus 1 is equal to r squared, where r squared, the radius squared, is equal to 50. So right here, we now put in 50 in for r squared, and we have the equation of the circle for this problem. So we have x plus 1 squared plus y minus 3 squared is equal to 50, right? R squared, radius squared is equal to 50. And so that's the equation of the circle. Okay. All right. I gotta take attendance. So tomorrow or Friday, we're off tomorrow, right? So Friday first thing, we'll find the x and y intercepts in the graph of this circle.